differential equations. Okay, and this is PDE. I will change this one. Okay, this will be, I have to change it. Rename letter, I will do it. Okay, PDE by Laplace transforms. So problems based on solutions of linear second order ODE with constant coefficients, and not only the second order, maybe third order, fourth order also, the higher orders also can be solved by Laplace transforms. And why we need this Laplace transforms? Okay, suppose my function or the problem y double dash plus 3 2y dash plus 3y equals to, suppose sin t cos t e raised to the power t square plus 5 and then t square minus e raised to the power minus 3. This kind of functions, not only this tan and cosecant, okay, and secant, cotangent can be solved by our method of variation of parameters, and as well as sometimes the method of undetermined coefficients, okay, few of the times. But suppose this kind of Heaviside function or the direct delta functions, if it is involved, then how can we solve that problem? So that time we need definitely the Laplace transform to solve that problem. Okay, is it clear? Yeah, give me the responses immediately.
Yes, sir.
Okay,
Yes, sir.
now the formula is for Laplace transform of uh, Laplace transform of y of t. Here it is written. Okay, here it is, everything is written. For your understanding purpose, I will write and then I will remove. Okay, Laplace transform of y of t is, suppose we are going to take it is y of s. Okay, and L of y derivative of t. Okay, L of y derivative of t means it is first order derivative using that formula. In our third module we discussed, it is s into y of s minus y of 0. This y of s actually came from this kind of things, s into L of y of t minus y of 0. So this can be written as s into y of s minus y of 0. The same way, L of y double dash, if I want to compute, then this is the highest derivative here is 2. So s square start with y of s. Y of s, only one term this y of s involved with this s only. Remaining all the conditions are conditions, the initial conditions along with this s. So s into y at 0 minus y derivative 0. Is it clear?
Yes, sir.
Okay.
Yes, sir.
So that's the conditions for applying a Laplace transforms in your problem. So this is the way here we are computing, or we are going to apply the things. Okay. So if it is, we are going to extend up to for the third derivative. So it is s cube, then y of s minus one order will reduce s square y of 0. Yes, then the derivative power it will be increased. So y of 0, y derivative of 0 and y double derivative of 0. Okay, y double derivative of 0. Okay, so these things we can do. And here it is y fourth derivative means s to the power 4 ys s cube y of 0 s square y derivative 0 s y double dash 0, and then without this s y derivative of 0. If you look at this, so here it is based on the order, the conditions will be there. Y of 0, y derivative 0, y double derivative triple. The number of initial conditions are 4, 1 2 3 4 for fourth derivative. 3 means 1 2 3. 2 means here is 1 and 2. 1 means only 1. There is no derivative means, only simply it is y of s. Are you got the point?
Yes, sir.
So
Yes,
it is
sir.
the case, yeah, it is the case for nth derivative. It's a case for nth derivative formula also there. Okay, if you are substituting n one second derivative, okay, second derivative means n is 2. So s square y of s minus s into y of 0. Okay, so here n is 2, right? Here n is 2. So that directly it is y derivative of 0. So that's the condition. This condition and this conditions are same. So in this way, the general formula also you may use it. And one more point here, not only this, if your problem depends on this y derivative, you may use y of s. If it is your problem depends on x derivative of t means, or it is x of t or x double derivative, this kind of thing means x of s we have to assume. If your problem depends on directly the function form means this f of s we are going to use. So based on this letter, okay, we are going to define our f of s also. Is it clear? It's for just the notation purpose we are using it. Okay.
Yes, sir.
Yes, sir.
Okay. Now it is a second order differential equations, d square plus 2d plus 5 into y. So nothing but it's nothing but y double dash plus 2y dash plus 5y equals to 0. Non-homogeneous second order differential equations with the constant coefficients. Since the order is 2, so we need two initial conditions. So y at 2 means actually y at 2 means it is y of t. Y dy by dt means it is y derivative of t. So at t equals to 0 means y of 0 is 2 and this y derivative of 0 is -4. Have you got the point? So how we are having these initial conditions? Okay,
Yes,
in the
sir.
statement wise also we can mention. So these are the alternative ways how this problem can be given. That is also given. Y means simply y of t because here it depends on t. This y solutions depends on t. Y derivative, this is y derivative of t. Okay, just consider the given differential equations, the homogeneous equations. This is an initial value problem. Can be solved by Laplace transforms. So we are going to take the Laplace transforms on both sides. Both sides we are going to take. So since the Laplace transform is a linear operator, so term by term the Laplace will be applicable. Okay, so that Laplace of y double dash plus 2y dash plus 5y equals to this Laplace of 0 will be here it is 0. Okay, because Laplace of constant is constant over s actually. So here it is 0. So overall it is Laplace of constant is it is 0. So L of y double dash plus 2 into L of y dash plus 5 into L of y. Okay, so now this L of y is can be replaced as y of s. This y dash is s into y of s minus y of 0. Y of 0. Y of 0. And this can be written as s into y of s minus s into y of 0 minus y derivative of 0. Okay, so using this, so here it is 2 is the constant should multiply positive 2 and here it is 5 times it is multiplied. So equals to 0. This is the equations. So for that here in detail here it is explained. Okay, here it is detailed way here we are explained. So the initial conditions are given at y at 0 is 2 and y derivative at 0 is -4. So that here y at 0 is 2 and y derivative at 0 is 4. Substitute here, and here wherever it is possible. Just apply the things. Okay, now this y of s only we are going to collect from all this left hand side of this terms. So s square plus 2s plus 5 is separately. Then after substituting the initial conditions, this minus 2s plus 4, then minus of minus 2, it is -4. Okay, -4. We are collecting it. So this 4 and 4 will get cancels. This 4 and 4 will get cancels. Okay, then here it is equals to 2s. Y of s, this term into this y of s equals to 2s. Now this y of s is nothing but L of y of t because initially we assumed that L of y of t is, here we have to assume let L of y of t is y of s. This y of t is y of s. Or in our previous slide itself, we have that. See here, L of y of t is y of s. This is the first assumption. Okay, remaining all the derivative formula. Okay, now we are having this. Now applying the inverse Laplace transforms on both sides, we will get L inverse of y of t is y of s, y of t, or this L inverse of y of s is L inverse of 2s upon this s square plus 2s plus 5. Okay, so the denominator can be written as s plus 1 whole square. So s square plus 2s plus 1, then this 2 square is there. So denominator can be written as in this way. But I have to take this s to the outside of this part, So here what I should do that? This can be written as s. S will be replaced as s plus 1 of minus 1. Am I right?
Yes,
Yes,
sir.
sir.
So add and subtract of these things. Then up to this. Okay, this maybe I will give in the other color. Okay, so I am going to consider this is s plus 1 separately. Then minus 1 is also separately. So that 2 times of this s plus 1 upon this s plus 1 whole square plus 2 square. This minus 2 times of s plus 1 whole square divided by 2 square. So here from this we know that L inverse of f of s plus a, if it is there, then e raised to the power minus as remaining L inverse of your f of s, nothing but, it's nothing but e raised to the power minus as into f of t. Okay, so this is the function value. So this minus 1 we may take outside wherever this s plus 1 form is there. So e raised to the power minus t remaining L inverse of 1 divided by s square plus 2 square, L inverse of 1 divided by s square plus 2 square, that is cos 2t. Here e power minus t here, then remaining it is L inverse of 1 upon r, this 2 upon itself, if it is s square plus 2 square means it is sin 2t. Are you got the point?
Yes.
Okay, so hereafter again the same type of problem, and if you look at the things, okay, look at the things. So I'm just trying to verify. Okay, the same problem can be solved our usual ordinary differential equations, right? Am I right?
Yes, sir.
Okay, the solutions now we are going to compare. So here in this method, the solution is 2 times of e raised to the power minus t, here e raised to the power minus t. So if I am taking here e raised to the power minus t as common, it is 2 times of cos 2t minus sin 2t will be the answer for this problem. So from this, write the auxiliary equations, if I'm going to write. So m square plus 2m plus y, the root will be minus 1 plus r minus 2y. So writing the solutions, e raised to the power minus t, c1 cos 2t, c2 sin ct. Just compare this e raised to the power minus t, c1 cos 2t, c2 sin 2t. So my c1 is 2, c2 is minus 1. That's all. If we are applying these initial conditions, y at t equals to 0 is 2, y derivative at t is equals to 0 is negative 4. Just finding the derivative of this, and supply the limits, then we can find the value of your c1 and c2. So it is, if we are going to replace it, the answers will be same. Okay. So while we are solving the ordinary differential equations in your usual method, as well as in your Laplace transform, both are same. Is it clear now?
Yes, sir.
Okay, fine. Now solve these ordinary differential equations. Now the non-homogeneous part contains an constant. So let here we are going to assume that this x of t is x of s. So L of y x double derivative. So we are going to frame these equations in the form of x of s. So s square x of s minus s into x of 0 minus x derivative of 0 minus 3 times of s into x of s minus y x of 0 plus 2 times of f of x. All these left side terms, of here it is listed out. Okay, this will be equals to Laplace of constant is constant by s, 2 divided by s. Supply the limit x at 0 and x derivative at 0. So whereas 0 and 5, so here 0 and 5, 0 we are substituting. So these two terms get vanished, remaining the term, collecting the term x of s alone, s square minus 3s plus 2, s square minus 3s plus 2. It is nothing but your auxiliary equation. It's nothing but your auxiliary equation. See here it is m square minus 3m plus 2. You are going to write your auxiliary equation. The same in terms of s, here we are having s square minus 3s plus 2. So it depends upon the root of that your equation, algebraic equations. So 2 divided by s. Okay, here it is s of 0 is vanished. Here minus 3 into s of 0 is vanished. So minus 5. So here 2 by s plus 5. Taking the product of these things are the factorized term of this. Okay, so I may get this 2 whenever I get the multiplications, and it is when they are adding, so minus 1 and minus 2. So it is s minus 1 and s minus 2. So 2 plus 5s upon this s square minus 3s plus 2 is this s minus 1 into s minus 2. So this is our Laplace transform of x of t, or this x of s. So now if we are going to apply the L inverse, so the thing is that here in the previous problem, it is in the simplest way. Here we are having just adding and subtracting. We just taken in the easiest way. But this kind of functions, whether it is in the product form, we have to apply the convolutions method or the partial fractions. Okay. By partial fractions, now we are going to solve it. Okay. We discussed many methods, right?
Yes, sir. Yes, sir.
Okay, by partial fraction method. So it is a repeated root case. So here it is highest term is, it is 2. Here it is degree is 1. So that here we are having that is proper fraction. So here A by S, B by S minus 1, and then C divided by S minus 2. Compute this ABC value. After computing that, is taking the L inverse on both sides. Okay, so L inverse on both sides of this one. Okay, by inverse Laplace transform. By inverse Laplace transform. So that it is L inverse of 5s plus 2 divided by s square minus 3s plus 2. So 1 by s minus 7 divided by s minus 1 plus 6 divided by L inverse of x minus 2. This is entirely, it is constant 1 minus 7 times of e raised to the power minus, here positive t, L inverse of 1 by s is 1. And here it is, if you're taking L 6 times of e raised to the power 2s, L inverse of 1 by s. That's all. The solution is solving the ordinary differential equations by which method? Students?
Partial fractions.
The original one is Laplace transform, and with the help of partial fractions, we solved, right?
Yes, sir.
Yes, sir.
Yes. Okay, but now the same problem, okay, if we solved by the ordinary method. This is my auxiliary equations, right? X square minus 3 x. The factors are 1 and 2. So roots are 1 and 2. Factors are minus 1, minus 2. Roots are 1 and 2. 1 and 2. So e raised to the power t, e raised to the power 2t, easily we can get. E raised to the power t, e raised to the power 2t. So this one, it coming from your non-homogeneous term. It is 2 divided by this x coefficients. If we are using that, it will be 1. So that is your particular integral solutions. Is it clear?
Yes, sir.
Mm. Mm. Now, it's a third order differential equations. And if you are look at this problem is something special because this is a non-homogeneous term containing, it is product of this exponential and this t, right?
Yes, sir.
Sometimes it is 0, sometimes some constant numbers, but it is purely a functions will be involved. So this f of t, this is f of t. So this f of t can be any one of the form, algebraic form, exponential form, the trigonometric functions, anything it can be have. Okay, anything we may have, but here the product forms also, which is allowed, the product forms also allowed, so that here Laplace transform just we are getting, since it's a third order, so the 3 initial conditions from starting from y at 0, then derivative, second derivative, we are having the answer is provided. Now, if we are solving this, the right hand side only I'm going to consider the Laplace transform. So since we know that the results of the shifting theorems and all, so Laplace transform of t square is 2 factorial divided by s cube. With this, if it is an exponential function, if it is multiplied, then that s will be replaced by s minus a, right?
Yes, sir.
Okay, so using this we are having. Now it's in the form of y. So L of y of t is nothing but y of s. Then here taking the Laplace transform, taking the Laplace transform on both sides of the differential equations. Okay, so here s cube y of s minus s square y of 0, s into y derivative 0, s minus y double derivative of 0, then minus 3 times of this plus 3 times of this minus y of s minus y of s. Now with using this directly be able to write. Substitute your y0, y derivative 0, and y double derivative 0. It's purely 1, 0, minus 2. Okay, so that I am just having this results 1, 0, minus 2. So collecting this y of s separately, this is my equation, auxiliary equations form, and minus s square, y of 0 plus 1, y derivative of 0 is 0, y double derivative of 0 is minus 2, and like this here, and here. 1, 2, 3. These three places here we are going to substitute. Then here minus of minus 2, it is positive 2. It is positive 2. And here it is minus 3. So from this we are having this minus 1. With this we are having minus 1. Then minus s into 0. Okay, plus 3 into 0. Okay, these two gets vanish. Okay, these two gets vanish. Here plus 3s minus s square. Then this minus 1. It's a common part here we are having. Then this term s cube minus 3s square plus 3s plus 1 is can be written as in the form of a minus b whole cube, means where a is s, b is 1. Then we can have this term as s minus 1 whole cube. Okay, so this term can be written as s minus 1 whole cube. Now my right hand side, all this entire term, we just bring it to the right hand side of this one. So s square minus 3s plus 1, and this one, now this s minus 1 whole cube, if I am bringing to the or multiply 1 divided by s minus 1 whole cube on both sides. On both sides, this is the actual meaning, multiply of this. Okay, so this get cancelled. So L of y of t is y of s. 2 upon this s minus 1 whole cube will be now, it is 6 because of this 3, and this s square minus 3s plus 1 divided by s minus 1 whole cube. Still it is proper fraction. This also proper fractions, right?
Yes.
Am I right? Okay, so
Yes,
this, so this s square minus 3s plus 1 can be written as, because of this s minus 1 term, simply we are going to adopt this without using the partial fraction technique. Here it is x power 6 is there, right? Which means that 6 constants you have to compute, right? Is it clear? If I am applying for this itself, this term itself 6 component, and this term itself we have to compute 3. So overall 9 factor you are going to compute, right?
yes, sir.
So to avoid that, just
Yes, sir.
using the add and subtractions method. Okay, so this term can be written as s minus 1 whole square. So s square minus 2s plus s is there. Okay, s square minus 2s plus 1. Then minus s if I am writing. So this is equals to x minus 1 whole square divided by minus s. Okay, s minus 1 whole square minus s. So simply we can write this. Now this minus 1 we can take out. Okay, so this term and this term, if you are writing in terms of sum of two terms, then here also this s is there, but here it is s minus 1. Then after that, here subtracting and adding this minus 1 and 1. So now this term is divided into, actually from these two terms, by without using the partial fractions, it can be extended to up to 4. Number of terms are, it is 4. Now if you are applying the L inverse on both sides, see here, 2 upon this s minus 1 whole square, 1 upon s minus 1, s minus 1. Now if we are grouping this, s minus 1 upon this s minus 1 whole cube, then this minus 1 divided by this s minus 1 whole cube, and this get cancels. Okay, this and this get cancels. So the remaining number is 2, right? So 1 upon s minus 1 whole square, if we are having that. Okay, now applying the inverse Laplace transform, take this minus 1 outside, e raised to the power t, then 1 upon s power 6 means, sir, what about this L inverse of 1 divided by s to the power 6? So it can be considered as 1 upon s to the power 5 plus 1. Am I right?
Yes. Yes,
So
sir.
this is nothing but t to the power 5 divided by 5 factor. Is it clear?
Yes,
Yes,
sir.
sir.
So like that, the remaining numbers also based on, it is 3 means it is t square divided by 2 factor. Here it is 2 means it is 1 plus 1. So t power 1 divided by 1 factor. Here it is only 1. So directly we may take L inverse of 1 by S. That's the idea. Okay, using this L inverse of these things. This is the resultant of your given problem for the third order differential equations with Laplace transforms. Now, sir, up to this, is it okay?
Yes, sir.
Yes, Papa. Now, using this second order differential equations, now right hand side is sine 2t. Sine 2t. In your exam, some of you solved this particular integral part in this method. 1 divided by d square plus 4. Then this sine 2t, taking this 2 is negative of this minus 4. 2 square is 4 plus 4. It is 0 sine t. So to avoid that, multiply and divided by t. So t times of sine 2t divided by 2d. So now if you are substituting or adding something, this kind of method, this method is called operator method. This is not in our syllabus. So that's why even some people are solved in the class. I cannot allot the full mark. So next time in the FAT, if you are writing 0 mark only. Okay, that's not in our syllabus. Maybe some teachers or professors without knowing that they may be given the mark or they are going to teach in the class, but it is actually not in our curriculum, that our method. Okay, now, so apply this, both the sides Laplace transforms, supply the unit initial value conditions, y at 0 is 3, y derivative at 0 is 4, supply the initial conditions. Now the term is divided into 3 terms. Okay, so how can we solve this problem? It is s square plus whole square, 2 square whole square. The thing is that L inverse of 1 divided by s square, 2 square whole square. If it is this whole square is not there, if this whole square is not there, okay, if it is not there, then it can be solved easily, right? So multiply and divided this 2 and 2, 2 and 2 can we get easily? It is 1 by 2 sine 2t. Am I right?
Yes, sir.
Okay, so now it is, since 2 is there, if I am applying partial fractions, then again it will be very lengthy. So to avoid that, to get this term 1 in the numerator, 1 in the term numerator. So what here we are going to we do it s square plus 2 square minus s square minus 2 square. So what will be the answer? So this s square will get cancels. 2 square is 4. Then this plus 4, 8, right? Numerator here it is there 8. So that 8 will be divided here. 1 by 8 of this 8. So this 8 and 8 will get cancelled. So remaining L inverse of 2 upon this s square plus 2 square. The same portions only in the numerator we are going to get. Am I right?
Yes, sir.
Okay. So now this is a small adjustment. Here it is cos 2t. Here it is sine 2t. It's very simple. Now dividing the term with this term and with this term, get it's a product sum of two terms. Now this is the resultant of t times cos 2t. Check your previous results are the module number 3, and it will be this term and this term get cancels out. This s square plus 2 square and this term will cancel. So 1 upon this 2 square plus s square plus 2 square, multiply and divided by this 2 and 2. So it is 1 by 4. If we are cancelling this, this is 1 time and this is 4 time. So 1 by 4 and multiply and divided by this 2 and this 2. Okay, am I right?
Yes, sir.
So it is 2 divided by s square plus square sine 2t. Okay, so in this way also we can solve. Not only this, even integral equations also. Determine the solutions y of t which satisfies these equations. Since it's the first order differential equations, look at these equations. This is a differential term and integral term, both are involved in my differential equations, and it is a non-homogeneous term. So that using the initial conditions, because of this first derivative, only one initial conditions, taking the Laplace transforms on both sides. Okay, so we know that Laplace transform of 0 to t f of t dt means which is 1 by s f of s. So here in the form of y is given. So it is 1 by s y of s for this integral term. Remaining it is s into y of s minus y of 0 plus 2 times of L of y of s. This is y of s. Okay, this is my y of s. And this y at 0 is 1. This y at 0 is 1. Simply replacing this. So this is s plus 2 times of y of s and this y of s. Y of s here, here, here. 3 terms here we are having. Then it is 2 times minus y of 0, it is minus 1. Here 2 times of s upon this s square plus 1 square. So these are the terms, taking the LCM of this and bringing to the right side. Entirely here we are having in this way. 2s plus s square plus 1 square. So this is nothing but s plus 1 whole square. Am I right?
Yes, sir.
Okay, this is fine. So here my right side is also I'm having this. Left side also here we are having this. Okay, so just get cancels out. So 1 upon s here, 1 upon s square plus 1 square. So bringing this s to the numerator up to the right side. Okay, so now if we are applying L inverse of y of s, this is my y of t, which is nothing but cos t. Okay.
Yes, sir.
So in this way, we are going to solve the problem for solving ordinary differential equations using Laplace transforms. Once if we know the basic Laplace transform formulas and the inverse Laplace transform, as well as the convolutions also, then we are able to solve this type of problem. Okay, and after that, in Heaviside functions we discussed, right, in last class. Am I right? Do we have this? No, not this. Yeah, this one we discussed in the last class, right? How to write a function of t if it is a piecewise functions in terms of the Heaviside functions. Is it clear?
Yes, sir.
Yes, sir.
Okay, so with this, I just remove these portions. Okay, and now we will write. Oh, is everything removed out? Do we have that file or not? Inverse Laplace transform. That file is itself removed. I shall do. Yes, that file is okay. I will retrieve from somewhere.
Sir, did we complete module 4 or still anything is left over, sir?
What?
Module 4 is completed or still anything is left over, sir?
Module 4 is the half of the thing is done, pa. Actually, it's a module 3 and 4. It's a cumulative part, right? It's a cumulative part only. So that's not an issue. Okay, because you know the Laplace transforms, right? Inverse Laplace transforms and Laplace transforms, if you know that one, then the solving ODE is very simple. Okay, so this class we discussed, right? So this PDF material I will share, pa. So whatever I written, okay, I think that's now removed from my system. So using this impulse functions, we have these types. Okay, that t minus 2 whole square in the last class we discussed, and this inverse terms also. Yeah, with this I will do that. Okay, so this is my f of t equals to h of t minus t. So this f of t can be written as 0 times h of t minus 3 plus t into h of t minus 3. So that f of t is still we are having that t into h of t minus 3. Is it clear?
Clear, sir.
Yes, sir.
Okay,
Yes, sir.
these things we are having. With this, consider the given problem as y double dash plus 4y using this f of t, where it is f of t, since it is a piecewise functions, but it is can be written as in the form of Heaviside functions. Is it clear? So taking L inverse on both sides, Laplace transform L of y double dash plus 4 times of L of y equals to Laplace transform of t into h of t minus 3. Okay, t into h of t minus. This is nothing but s square y of s minus s into s square into y of 0 minus y derivative of 0 plus 4 times of y of s. This will be equals to, sir, Laplace transform of h of t minus 3. If we want to get, then what we should do? Laplace transform of this t minus 3 plus 3 times
Subtract
of
and add 3.
h of t minus 3. Add and subtract, right?
Yes, sir.
So this term will be written as t minus 3 into h of t minus 3 plus 3 times of h of t minus 3. Is it clear?
Yes,
Yes,
sir.
sir.
Okay, then now it can be written as sum of two terms. So add and subtract. Add and subtract. Okay, so this 3 I will write in the form of inside the interval, because last class also somebody asked. Okay, so this 3 I'm going to maintain under Laplace 3 times h of t minus 3. Okay, if we are doing that, so what will be the answer here? Right hand side part, e raised to the power minus 3s or s.
It's just 3 years, no, sir.
Okay, 3s. Then it is Laplace transform of t alone there, plus Laplace transform, here it is e raised to the power 3s. Laplace transform of 3 will be there. So e raised to the power 3s is common, and it is 1 by s plus it is 3 by s. Is it clear? Left side, the initial
Yes.
conditions, y at 0 and y derivative both are 0. So here I can get this. It is 0 and it is not this term. So this is also 0. So y of s is s square plus 4. Okay, so y of s, it is s square plus 4. Here we are having it. Okay, now, sorry, but this is minus 3s only. Pa. See that Laplace transform of f of t minus a into h of t minus a is e raised to the power minus as, and I think divided by s is also there, right? What about the condition? See, e power minus as
Yes, sir.
into f of s, right? Here it is minus a only. Plus if it is coming in, then only here it is by plus. Okay, so it is minus a. So, okay. Consider this result. You using this results. So it is e raised to the power minus 3s only. Minus 3s. So the same form here we are having that, which is y of s equals to, this is 3 plus 1 e raised to the power minus 3s by s, and this will be 4, right? Am I right? And divided by s square plus 4. Divided by s square plus 4. Now we may apply partial fraction. So to solve this problem. Is it clear?
Yes, sir.
Okay, and the partial fractions without this e raised to the power 3s, because it's a common term, 1 divided by s into this s square plus 4. For this, computing the value a divided by s plus bs plus c divided by s square plus 4, we have to compute the value. Okay. For this 1 by s, am I right? Laplace transform of t is what? Laplace transform of t. Students?
1 by s.
No, constant means constant by s. T square. This one, then here it is s square, right?
Yes,
Yes,
sir.
sir.
So here it is s square will be there. It is 3 by s. Then we cannot add it, right? Simply we cannot add like this. Okay, simply we can't add this. E raised to the power minus 3s e raised to the power minus 3s, and this L of t plus 3 into e to the power L of 3. So 1 upon s square e raised to the power minus plus 3 by s into e raised to the power minus 3s. Now this s square plus 4 overall my y of s. Overall my y of s can be considered as okay. So this is from the L of t form. Right hand side we are computing here. This is only the right hand side they are evaluated. So this can be computed here itself. We computed in the blue colored one. Okay. So this is s square plus 1. This right hand side functions. Now if we get this 3 to get this LCM of this 1 plus 3s of e raised to the power minus 3s upon s square is the common term, and then it is s square plus 4. Suppose we are having that. So for this, apply inverse Laplace transform, and before that the partial fractions. Okay, partial fraction. Then we need when we can get this kind of things. Okay, see, look at this answer. Look at this. This e power minus s will be present in your all the terms. Am I right? Am I right?
Yes, sir.
So consider this term. So then how to write this? How to write this? It is a proper fraction. The proper fraction. This should be computed by partial fraction technique, right? Tell me the right hand side.
Yes.
as plus b by s square.
AS s square or s? First, this s square is there, right? Am I right? Because this is s square is nothing but s minus 0 whole square, right? Roots are repeated case. Okay, 2 times we have to do it. And then it is a squared one and it is 1. So what will be the things? S square plus 4 term is
So CS plus D.
CS plus T. Yeah, you are right. If I'm doing that, then this 3s plus 1 will be same as with a into s square plus 4. One more s shall I write here? As.
Yes, sir.
Okay, as, because when I am dividing this s into this s square into s square plus 4, one s and s square will be get cancelled. So a by s only there. Then here it is b into s square plus 4 plus cs plus d into s square only.
S square.
S square. Now, if you are substituting, which number we are going to select?
So I think here we should compare the coefficients only.
Coefficients. First, we need some value, right? Then only the coefficients we may collect. Are you interested to collect S term only?
Sir, excuse
Yes,
me,
pa.
sir.
Yes, pa.
Sir, I have my electronics extra class now.
Yeah, you may go, pa. You may see the
Thank
video
you.
record, right? You may see the video record.
Yes,
And
sir.
drop
Thank
your
you, sir.
name number. Drop your name number in the chat.
Okay, sir.
Okay. Then how can we calculate this? S coefficient. Suppose we are going to calculate S coefficient. Just collect the things. 3 equals to, it is A, right? 4 times A. Then here it is. Here it is. There is no
Plus
term
D.
because it is CSD, right?
Yes, sir.
So A is 3 by 4. Then S square. S square coefficient 0, 0,
B
B,
B plus D.
B plus T. So with this, no informations we cannot get, right? Simply the relations, B is nothing but minus T. Then constant, 1 equals to 4B,
4B.
4B. So which implies that B is 1 by
1
4.
by 4.
Implies
D
that
is minus 1 by 4.
E is minus 1 by 4. Am I right?
Yes, sir.
Yes, sir.
Or we can write here itself. And D is minus 1 by 4. Then what about C? Just x cube coefficient,
Sir, A plus C.
0, and then A plus
A
C.
plus C.
So C equals to negative A.
Minus 3 by
Is that
4.
C equals to minus 3 by 4. So if you look at this equation, so with this 3s plus 1, okay, 3s plus 1, okay, A is 3 by 4. This is 3 by 4. Okay, I may write here also 3s plus 1 divided by s square into s square plus 4 equals into this 3 power minus s. Here we are having that. Okay, and don't ignore this e raised to the power minus s. Still it is there. So e raised to the power minus 3s will be the common term for all the things. Okay, a is 3 by 4. 3 by 4 into 1 by s. This 3 by 4 into this 1 by s. B is 1 by 4 plus 1 by 4 into 1 divided by s square plus cs plus d. cs plus d. So minus 3 by 4 s plus minus 1 by 4 divided by this is here we are having that s square plus 4 s square plus 4. Now if you are applying the inverse Laplace transform on both sides, so this e power 3s is still we are having that, right? This e power 3s, e 1 by s, e power minus s, here it is e power minus s divided by s square plus 4 with this term, s square plus 4 term. And this is 1 by 4 s square into e power minus s. And it is minus 1 by 4 s square plus 4 into e power minus s. Now applying the inverse Laplace transform on both the sides, on both the sides of the integral, sorry, this Laplace transform terms. Okay, so here L inverse on these terms. Okay, then this is entirely it is y of t, right? Because it is my y of s. The terms are it is my y of s. So L inverse of y of s is y of t. But how to write this e raised to the power this 3 by 4 we take outside, then L inverse of this 1 by s into e raised to the power 3s is first we are going to consider this L inverse of 1 by s. This is t, this is t. Then this t will be replaced by this using this a t minus 3 into this h of t minus 3. Okay. No, L inverse of 1 is constant only, right? No t. Am I right? Sir?
Yes,
L
sir.
inverse of 1 by s is 1, right?
Yes, sir.
L inverse of 1 by s is yes. With this we are going to replace by this. There is no t, so it is only multiplied by h of t minus 3. Then next thing, this is for your understanding purpose. Okay, using this negative 3 by 4 L inverse of s divided by s square plus 4 into e raised to the power minus 3s. So minus 3s, this is minus 3 by 4. This is nothing but cos 2t. Am I right?
Yes, sir.
This t will be replaced by using
2
this 3,
minus 3.
using this t, right? The 3 into that your h of t minus 3.
Minus 3.
Okay, that's why here it is minus 3 by 4. Minus 3 by 4 cos of 2 times of this 2 minus 3 into heavy side or unit impulse, unit step of this t minus 3. This term here we are having. Just comparing these two. And this term, this is 1 by s square means L of t, sorry, it is t. T means t will be replaced by t minus 3 into h of t minus 3. So that is the answer here we are having. And it is 1 upon this s square plus 4 means multiply and divided this 2. So this will be sine 2t, that t will be replaced by t minus 3 and h of t minus 3. Is it clear?
Yes, sir.
Yeah. So in this way, in your, if it is any heaviside function, heaviside functions, the answer will be involved with your heaviside functions. Sometimes maybe the constants also there. Based on the problem, it will be there. Okay, so this is the answer for your problem. Okay, and here that problems also, when it is t less than 3, it is 0, t greater than or equal to 3. This will be the solution, the entire solutions of your problem. Okay, if you want to analyze the problem, if you want to analyze the given problem, okay, then we may plot this in MATLAB. We can get the solutions of that given problem. Okay, now I may take around 5 minutes. Okay, because at least I have to cover this heavy side part. Okay, and consider this graph. Consider this graph, y double dash plus 4y. We may have it. We may have it. Okay, this 3.17 is the solution of this graph. Okay, solutions of this graph. This graph is for your previous problem or your this problem, right? Y double dash plus 4y equals to f of t. F of t is 3 less than t less than 3, t greater than or equal to 3. So this is the solution of your given problem. Okay, so this is the solutions. Now the problem is over. See, up to that 3, it is 0. Okay, when t, sorry, in this way we are having, oh, this is solution curve, right? Solution curve y of t. Okay, now I just related with these things. Okay, that's why I confused. Okay, now consider the function. This is my f of t. This is my f of t. This can be written as, this f of t can be written as using the unit step function or heaviside function. So sometimes it will be written as this form also. Instead of this h, they may be used u also. Unit step function of it is t minus 2. Okay, plus t minus 1 into this unit step of this t minus 2 minus u of t minus 3 plus minus 4 of this u of t minus 3. So here this h will be replaced as u. So h of t minus 2 minus h of t minus 3 into this t minus 1 because of this 0. Remaining it is t minus 3 into minus 4. Okay, so this is my function. And this kind of impulse functions, until this 2 is 0, until this 2 is 0, from the graph itself we have to write the function. Graph itself we have to write the functions. So my f of t is can be written as t less than 2 is up to that it is 0, and it is an open part. Okay, it has the discontinuity. See here it's an open circle. Okay, and it is from here it is t is equals to 2 because it is shaded. Okay, then less than 3 because at 3 it is having the punctured disk. Okay, there is a hole. Okay, then this will be denoted as, here it is the slope. If I'm using it is t minus 1, it's a line. Okay, then t is greater than or equals to 3, t greater than or equals to 3. From this onwards it has the value, it is minus 4. So this is my function. This is my functions. So in this way we are having that. Okay, the applications part of this problem, using the circuit theory as well as in even mechanical vibrations problem also, consider this circuit. Okay, so this is the output part and this is the key section. Okay, so here it is the key. Whenever it is in the B stage, it is off. So this switch, if it is on, so this line going to join here at the point at A. So there is a power will be going on into the circuit, So A is on. A is at the point of this on mode and then this B is off. B is off. So A is on and this is B is off. So whenever it is A switched on, then here it is the power will be generated. So the output of or the electromotive force we may have it. So with this we are going to solve that problem. So we want to compute the output voltage on this capacitor. Read the problem using this figure 3.1. Initially has the zero charge. There is no charge. There is no initial current. Okay, at time t equals to 2. At time t equals to 2 seconds. Okay, the switch is thrown from the positions B to A, which means that we are going to switch on the network. Okay, held there for 1 second, so that initially we have 2 seconds. Now it is t equal to at 3 seconds. It is 3 seconds. Then switched back to B. Okay, on off. That's all. At the third second. For this, we have to frame the differential equations. So here we are going to use it for the things with the unit step functions. Okay, so here at how many units we are having? 10 voltage, right? Figure it is the message is given, right? When you are switch on this, at third second we are having 10 voltage. Initially at it is 0. So that here we are having that in the map. Suppose I am going to have at the point 2 second and 3 second it is 0, and that at it is 2 to 3 it reaches it is 10 voltage. Am I right?
Yes, sir.
Okay, so using this h of t minus 2 and minus h of t minus 3, we have that it is E of t is 10. And by Kirchhoff law, this using this circuit diagram, we may have this ODE. We may have this ODE R into I of t divided plus 1 by C into Q of t, which is E of t. E of t is also here you are having. Then R is what? So it is 2,50,000 ohm is there, right? On the resistance part. Okay. And your capacitance, it is 10 to the power minus 6 farad. Okay, minus 6 farad. Okay, fill that numbers 10 power 6. Actually, it is 1 by C. C is 10 to the power minus 6. So overall, it is 10 to the power 6 Q of t. So that here, now applying the Laplace transform on both sides, 2,50,000, 2,50,000. Okay, 2,50,000 of my Q derivative of t. Okay, Laplace of this plus Laplace of, okay, actually 10 to the power 6, Laplace of Q of t, which is equals to Laplace of 10 times of h of t minus 2 minus h of t minus 3. So for this Laplace first derivative means q, so that q of s I may write, or here they may be used q of t. Okay, usually we are using that Laplace of q of t. We may assume it is q of s, means we can use q of s. Okay, so here also they are using q of s, right? At the end they are using. Initially we can do our process. So E of t, substitute your initial conditions q of 0, because it's initially there is no charge, right? As 0 charge initially it has 0 charge. So q of 0 is 0. Q of 0 is 0. So now find the right hand side Laplace transform. L of h of t minus 2 is, it is e raised to the power minus 2s, and remaining L of h of t minus 2 is nothing but 10 times e raised to the power 2s minus 2s, and remaining L of 1 is there. So 10 into e raised to the power minus 2s divided by s. So it is here, and then here it is by minus 3s divided by s, and it can be written as in this form 10 to the power 5, 10 to the power 6. So this 10 get cancelled somehow. So remaining here we are having these numbers. Now applying the partial fractions overall, that without this e power minus 2s and minus 3s, if you are solving by partial fraction, here one partial fraction, here on partial fractions. So totally we are having 4 terms, this term, and this. Okay, so now using the shifting theorem, we can get the solutions of this problem. Everything can be written in the form of the unit step functions like our previous. Sir, is it clear?
Yes, sir.
Okay, with this, I will stop. In the tomorrow class, I will start with the unit impulses and direct filter functions. Okay, the material right now itself I will share. Okay, if you are having any doubts, okay, and then please note it. And then tomorrow class we will discuss. Okay. Okay, students.
Yes, sir.
Okay, ma. Okay, ma. Thank you. See, the thing is that why I am telling. So here, this module number. Four. Okay, four is partially we covered this unit step function and unit impulse function, which was the concept, basic concept, which is available in our third module. So you said solving ODE is fourth module. So in your fourth module, we have only two things. Only the things like finding the Laplace transform of or solving ODE by using direct delta function, and then solving system of ODEs by Laplace transforms. Only these two topics which is pending in our module number 4. Okay, maybe solving first order ODE. That is very simple. Around 5 to 10 minutes we may use it. Then fifth module I am going to start it. The 4-year series. Okay. Thank you.
When
Thank you.
you'll start, sir, fifth module?
By tomorrow, if it is, if I am taking the enough time means, then by tomorrow the module number 4. Right now it is around 60%. So 30% tomorrow I will try to cover. Then 10% Thursday morning class I try to cover. Okay. So from Thursday and Friday I try to cover your module number 5. First 2 sections only for your exam. Up to C2, C plus 2L only. Not half of the module. Okay. In
Okay,
module
sir.
number 5. Yeah. Hopefully I will give you all the materials and the supplement things. Okay. Don't, and parallelly you try to solve your not digital, your tutorial sheets. Then only you may get the ideas. Okay.
Okay, sir.
Okay, pa,
Sir,
thank you.
upload the materials, sir.
Yeah, this material I will do it, pa. And your last class, that which one we have to share it? That is ODE part, right? So module
Yes,
3, 4, 5, everyday basis, whenever I'm going to write, I will update it. Okay, module 3, 4, 5. Once I started the 5, I will do it. Remaining right now, check the materials in 3 and 5 as well as. Okay.
Okay, sir.
Okay, pa,
So
thank you.
module 5 is also gonna come in.
No, module 5, I think Thursday only I can start. That time I will upload. So right now you check with the materials updating in module number 3 and 4. Okay.
Okay, sir.
Okay, ma. Thank you. Thank you for giving me
Thank
your
you, sir.
valuable time at the evening.